Hi, we're the Laguna Beach High School Invent Team, and we are currently working on a project for the Lemelson MIT Invent Team program, where we're attempting to design a solar-powered water purification system using the power of the sun and the power of chemistry. Ultimately, our goal is to bring clean drinking water to the Uluwai Mutia Elementary School in Masai Mara, Kenya. We've done research on their school and their surroundings and have told them that this is for a research purpose, and we're hoping to get some producible results that we'll continue to work on, if not this year, then in years to come. The way our device works is that we start with a holding water, contaminated water, which comes from the river or wherever else a contaminated water source would be located. And essentially what happens is that we have a hydrogen peroxide generator, which we're using the catalyst anthraquinone to generate hydrogen peroxide over time. We have a ball valve, which controls the flow rate of the water going into the acrylic tubing. This flow rate is combined with the amount of hydrogen peroxide needed to purify the water. So we have a set amount of water in hydrogen peroxide solution going through acrylic tubing, which is clear so the UV light can pass through it. And it goes through the tubing for a certain amount of time, controlled by the ball valve. And the parabolic reflector here has a mirror surface which reflects UV light directly into the acrylic tubing and breaks apart the hydrogen peroxide into free radicals, which then kill all microbial life. Once the water is cleaned, and as it has been in the tubing for the long enough amount of time with the hydrogen peroxide solution needed to purify it, it will go through to the sterilized water container. If our electrochemical bacterial sensor is successful in their endeavors, then we'll be able to combine their project with ours to test for the water sterilization.
Hi, I'm Nolan Gonzalez, and I'm head of the Department of Hydrogen Peroxide Generation. In Kenya, our hydrogen peroxide generator will work off of hydrogen peroxide being combined with water and getting shot with UV light. Since it's expensive to put hydrogen peroxide inside and send it to Kenya, we're going to produce it on site. That is what our team is working on currently at the moment.
So far, we have tested anthraquinone, which is our catalyst, in 2 different types of alcohol, isopropanol and ethanol. So far, our results have come up that ethanol produces the most hydrogen peroxide, and next we're going to test a container that will send in the most UV light.
I'm head of the construction team, and our goal is to create a parabolic reflector to focus the UV light. And as of now, in natural conditions of around 1200 milliwatts per meter squared, the parabolic reflector focuses that to 2000 to 2200 milliwatts per meter squared. And the reason this happens is, compared to a flat reflector where the light just bounces back, on a UV reflector, or on a parabolic reflector, the light bounces back and all gets focused on one point along the parabola. And that's where all the increase in UV comes from.
Hi, I'm Hallie. I'm head of the department creating the electrochemical bacterial sensor. Our basic plan is to layer the blue electrode provided with the Wave Now setup kit with polyethyleneamine, which will then attach to the phage, which is immobilized virus, which will detect bacteria, specifically E. coli.
So far, because the experiments we're running in order to develop the sensor require some specialized equipment, we've been working on gaining mastery of this equipment through several cyclic voltammetry experiments involving ferrocyanide solutions. We've just started layering the polyethyleneamine on the electrodes and are now fluorescing BSA, which is a protein, and this will also go on the electrodes as a sort of test run.
Hi, I'm Andrew Couch, and I'm the leader of the water sterilization team. Our main goal is to test the effectiveness of hydrogen peroxide sterilization, UV sterilization, and the combination of the two. Our main goal is to hope that the combination of UV and hydrogen peroxide sterilizations will yield much better results than either of the two alone. As of now, we've done hydrogen peroxide alone, and our results showed that a 32-fold dilution of 3% hydrogen peroxide does sterilize water. As right now, we're doing UV sterilization alongside the combination of the two to make better use of our time, and those results hopefully will show that hydrogen peroxide and UV light combined yield much better results.
We're really hoping that our project ends up being successful and that we'll be able to see tangible results. So far our progress has been pretty good, and we look forward to keep working on it and hopefully being able to bring back more pictures from Mulila Mutia with actual purified water.